This introverts are getting a little tired. I had to get some espresso going. I'm Ben Nicholson. If you don't remember, you haven't been in here. You are.
I'm Tristan Valencia.
Hey, and we're here to MC the studio room where we're going to hear from Samuel and Matrox here in just a minute. But we had a quick, important announcement.
One very quick announcement. We just want to remind everybody we do have a studio crawl at 5:30 today. We're going to go visit Hush and 510 for those of you that are interested. Feel free to find me. I'll be near the entrance, and we can walk our way over there. It's about a 10-minute walk, and we'll get to hear from Hush a little bit about their practice and their projects, and we'll hear from 510 about their custom LED work. So feel free to join us. Please come see me for a flyer if you'd like.
Welcome, Samuel, please. Samuel and Matrox are new to Framework, so thank you for coming, and we'll hand it over to you.
Testing, test, okay. Hello, everyone. I always like being the first speaker right after lunch when people are half asleep in the chairs. It's a privileged slot. Thank you for joining the session. Today we're going to talk about open standards for moving media on IP networks. I'd like to take a quick show of hands if anyone in the room has worked with SMPTE ST2110. Okay, so this is already a very acquainted crowd in general. We're going to do a little bit of an update on the continuing work of the committees and groups and organizations that helped support the building of SMPTE 2110. It turns out that the work has been continuing. The VSF is the group that originally developed TR03. That eventually became SMPTE 2110 when it was turned over to a standards body, SMPTE. But the VSF has been working on TR10. So the same group that built 2110 has built TR10, which is better known as IPMX. We're going to talk a little bit about that. So who am I? I work for Matrox, but I'm also the chairman of the Pro EV working group at AIMS. I've been spending the last 10 years or so working with the education about open standards and the promotion of the use of open standards on IP networks. So we'll do a little bit of a background because I think it's important to understand what's happening on your systems. And you could probably relate to this analogy. There was a point in your lives where you probably learned how to ride a bike, and it was hard at first, but then you became quite good and adept at riding your bike. And then when you got a little bit older, maybe some of you learned how to drive a car. And you can probably relate to, okay, after you learned how to drive a car, it was also pretty easy and just muscle memory. It was a bit more complicated to learn how to drive a car, but the utility of driving a car compared to riding a bike was also not comparable. You know, you could do a lot more with a automobile than a bicycle. So I like to use that comparison when we think of, you know, it was hard to build synchronized SDI systems, but once we learned how to do it, it became second nature, and we built some pretty phenomenal systems with that. Now that we're pivoting to IP-based systems, there's even more that we can do. There's a little bit more to know, but you know, it's really rewarding to embark on the next node in technology. This picture helps illustrate one of the challenges that we always face when it comes to media, so graphics and video and other media. There's a tug of war that is perpetual between reach and performance. So aspects of reach, you know, including things working seamlessly together, interoperability, the distances between pieces of equipment, just the flexibility in general. And aspects of performance, which a lot of the people in this room spend a lot of your days dealing with media quality and the ability to do advanced media processing and synchronization and low latency and experiential things. So historically, these things have been, you know, fighting, and there's never been a product that has been introduced or a standard has been introduced that could do, you know, all of the aspects of reach and all of the aspects of performance. So it's within that context that we talk about standards and what they're useful for. You probably also have a little bit of background with the evolution of audio over IP, so I just want to do a really quick review of the history of that, that's actually pretty mature. Audio over IP started a very, very long time ago. And one of the things that's really popular today that gets used a lot is Dante. That's already 20 years old. Can you believe that? That's amazing, isn't it? But it continued. You know, the development of things to do audio over IP didn't stop at Dante. There were things that were added afterwards that solved other problems. And one of the things that emerged that was very useful was AES-67, which was a bridge between audio islands. So if we look at the audio market, AES-67 allows us to share audio content between different audio vertical implementations. We can share AES-67 audio between all of these different things, QLAN and Dante and SMPTE 2110 and IPMX. And there's a few things that don't natively support AES-67, like NDI, but even for that kind of stuff, it's usually no problem. There are some companies that make converters that can help you convert between AES-67 capable products and NDI. So this is very encouraging. We're trying to get here with video as well. With video, it's a little bit trickier, and it's taking a bit more time, because there are things that have been optimized very differently for reach and for performance, and we're trying to make them meet, but it's very hard to make these things meet. Like the media that your cell phone supports, the reason that you can watch a 2-hour movie on your cell phone and still have 70% battery after that is because you have some pretty advanced hardware acceleration for a certain media type in your phone, and the media is delivered to your phone in that media type, so you actually have a very nice reach-based solution for that type of media. But we can't build, a sphere-like project or one of these experiential AV things out of, H.264. It's too compressed. It doesn't serve that need. So what's been happening is there's been a lot of innovations to take the reach-based solutions and add performance to them, and take the performance-based solutions and add reach to them. And the market has come up with some pretty good stuff. There's been 2110, NDI, SDVOE, Dante AV, and many other things. And some of them also support, some of the features that we need from either a broadcast facility or an experiential AV environment, such as, synchronized Genlock, or, the ability to use SDI signals across many devices with sync. So this is the progression of signals through time, and it doesn't really matter if the core software in the picture is routing centric or if it's media processing centric, but the evolution has hit both types of software in a similar time scale. So analog gave way to digital. So you probably remember when we started introducing digital video cables. I was there at the beginning of that. It wasn't HDMI or SDI at first. There were all kinds of weird things like P&D and MDR, and my God, that was really a dog's breakfast. And eventually sort of stabilized around DVI, and then eventually some pretty mature second wave things came out like HDMI, DisplayPort, and SDI. They all served slightly different markets and purposes, but they all became very stable for a long time. And now we're in the next wave, which is IP. So you remember some of these connectors? One of the things that is sticky is that there's still some of these in our lives. We still use some of these today. This is the next generation, and we still use a lot of this today, right? There's still quite a lot of this digital signal use. And then, of course, here's where we're at now. We're trying to harness the benefits of what we can do with wired and eventually wireless high-performance media over IP. In the meantime, we have these really incredible products that try to make sure that you can still use everything you need in your applications, and you can still convert almost anything that you need into your workflow if you look for the equipment. And that's actually a thing that we're going to cover a little bit in the conversation today. Is we've always used converters. So I'm sure that some of you have experience taking asynchronous signals like the output of an HDMI device and using some kind of a box or widget to convert the signal into something that could be used on a synchronized system. So it's a little bit harder to take an asynchronous signal and bring it into a Genlock system. Going in the other direction is easy. There's been a lot of passive adapters that can let you take the output of a processed media system on sync and then just distribute it to nodes that don't care about sync. So going between DisplayPort and HDMI to SDI, a little bit more challenging but possible, and going from SDI-based media processing systems to HDMI or DisplayPort distribution systems, very easy. But we've always used this kind of equipment, and there's still going to be a lot of use of this kind of equipment, but it's going to be for different types of conversions moving forward, so converting IP to IP. So we're not going to, with a crowd of this level of experience with IP, we're not going to spend too much time on the why move to IP, but this is an important picture. This shows us how, it's kind of unavoidable. The bandwidth capabilities of Ethernet are just so much bigger than what hardwired cables are keeping up with, and we're already using that capacity. There are systems being built today that have bandwidth levels that exceed what we're doing on baseband cables. So an important consideration. This is going to get more likely to see IP-based systems exceeding what we can do with hardwired media. So some of the advantages, right? The ability to have an unbalanced number of inputs and outputs on a system. So gone are the days of the video matrix switcher where you have 16 in and 16 out. Today you can have the number of inputs that you need for your workflow and application. You can have the number of outputs that you need. This is one of the benefits of going to IP. Of course, you have, the advantage of scale, the ability to put big distances between your equipment, or the ability to have a huge number of nodes on your system if you need. And of course, manageability. So one of the things that you can't do on a cable like this one here is talk to it, right? You can't see from a central software if this cable is plugged or unplugged or defective. So one of the points of going to IP is having information closer and closer to the critical equipment on your system, your displays, your cameras, your media processing equipment. It's very important. There's also some new notions that we're dealing with. This is part of going from the bicycle to the automobile. Yes, we have to know how to use the capabilities of our network-based media devices. So we have to understand a little bit more about networking. There's skills that come with building a competent performance media system. Bandwidth is another topic. We can fit audio comfortably on network bandwidth. Even super high quality audio like 24-bit, 192 kilohertz audio fits very nicely on a 1 gig cable. You can't fit full uncompressed video on that same network bandwidth. So even when you go to 10 gig, you can fit full HD, but you can't fit uncompressed 4K. So we have systems that can exceed these bandwidth levels. We can build very, very high bandwidth systems, and there's other applications where it's justifiable to compress the media, and there are some very, very nice compression solutions where you can maintain the high quality and low latency of a system while maintaining a lower bandwidth media network. So let's look at this picture again, the signals through time. Audio, we said, has been around for a long time. We've been doing video over IP for a very long time as well, but the real performance level of directly wired media over IP really started around 10 years ago, and the first projects that were introduced using some of the technologies that you're familiar with, ESPN was probably around 2017. The Crestron NVX was used for an esports facility at UNC Greensboro. The European Parliament was deployed on SDVOE. And a few weeks ago, I was at the grand opening of the new headquarters of JP Morgan Chase, which is one of the first really large size hybrid systems of IPMX and SMPTE 2110. So the topic is, how do we deal with these media systems over IP? And there's two really useful tools in our toolbox. One is the open standards, and the open standards address things like allowing assets to behave in a common way on networks, so being discovered in a common way, being able to send commands to them in a common way. It's also meant to allow different asset classes from different brands to share media. So with your previous generation technology, with HDMI and with SDI, you were able to mix whatever equipment you needed. If you wanted, a camera from one company, a media processor from a different company, and a display from a different company, this was never a problem. And as I said earlier, in the worst case, if you needed to convert from, one of those signals to the other, those little converter boxes were cheap, reliable, easy to use, didn't really need a lot of skills. So it was easy to mix equipment. Looking to maintain that ease of mixing equipment on IP is one of the things that we're working really hard to put into the standards. And of course, the ability to work in hardware or software. Sometimes the application that you're building, it's completely fine or even preferential to use hardware acceleration or hardware-based products. And sometimes, an entirely software-defined workflow or software-based products are either more appropriate to use or more flexible or more affordable. Whatever the case may be, we want the standards to not have dependencies for one or the other. They have to be able to live in either world. And then for converters, we already saw what the previous traditional hardwired converters look like. With IP, we're dealing with new types of conversions, but we're essentially going to do the same thing. Being able to convert things within a standard. So there are different media profiles within SMPTE 2110. There's SMPTE 2110-20, which is uncompressed video. There's SMPTE 2110-22, which is constant bitrate compressed video. One of the popular codecs that is used with SMPTE 2110-22 is JPEG XS. But there are converters that exist that allow you to convert from SMPTE 2110-22 to SMPTE 2110-20 or vice versa, okay? Another type of conversion that you may need is converting not only the media type, like uncompressed to JPEG XS, but also the media and the protocol. So for example, if you want to convert an NDI signal, the NDI full signal uses the SpeedHQ codec. So going from the NDI protocol with the SpeedHQ codec to either SMPTE 2110 with no compression, or SMPTE 2110 with compression, or NDI to IPMX. These are all possible conversions today. So this allows us to use more and more equipment and to sort of reestablish some of that inter-equipment compatibility, the ability to use sometimes software-based stuff or hardware-based stuff. We're trying to restore that as much as possible. Keep in mind, when you're converting from something that's compressed to something that's uncompressed, we're strictly dealing with equipment compatibility in that case. We're never adding back quality. I hope you understand that if something has been compressed and you're attaching it to a system that is using uncompressed media, you're not inventing back quality, but you're allowing the equipment to be used. You're allowing the compatibility to exist. So, a little reminder of the roots of SMPTE 2110. SMPTE 2110 was introduced as a replacement for media over IP for an SDI facility. The broadcast facility basically was the point of origin. SDI had a little quirk that emerged when it was introduced into the market. The color space was slightly compressed because most of the media that was put on SDI cables initially were cameras. And for live camera video, compressing the color space a little bit down to 422 was quite acceptable. It didn't really affect the image quality. The content was changing in a way that losing that slight amount of color information had no real impact on your application. So when we started to introduce the migration to SMPTE 2110, one of the mandatory media formats for SMPTE 2110 is 422 to be compatible with all of this SDI infrastructure. Now, SMPTE 2110 doesn't say that your product has to support YUV 422 and nothing else. So there are some SMPTE 2110 products that support 444 content as well, but they don't have to. And so that's why you have occasionally some surprises. When you're building a 2110 system and you buy a bunch of different devices that support SMPTE 2110 from different brands, you know, some of them only support 422, some of them support 422 and 444. You have to know when you're buying this equipment what that's about. The other aspects of SDI that were maintained with 2110 were the ability to have separately routable audio, video, and ancillary data. So that's stayed with 2110. They're separately routable flows. They each have their own bit stream on a network. And of course, synchronization. Very, very, very key part of a Genlock SDI system was the synchronization, and that was a top priority for SMPTE 2110 as well. Again, the spec, the way 2110 is written, doesn't prevent you from building a product that also works on a system with no PTP, okay, or no synchronization. But the product must support a grandmaster if it's present on the network. So the way it's written, you have some products that they only work if you put them on a synchronized system with PTP, and they don't work if you have no PTP on the system. And some products support both cases, so it's not super clear. So again, you have to know when you're buying your products if they're gonna work on the system that you're designing, depending on how you're designing your system. So one of the things we discovered after the introduction of 2110 and after the building of the first few projects like ESPN was we needed more than just the media to be handled by the specifications. We needed a common way to do asset discovery on a network and asset registration. So NMOS was introduced a little bit after SMPTE 2110, and ISO 4 and ISO 5 in particular made building SMPTE 2110 systems a whole lot easier. And so today, most SMPTE 2110 products also support NMOS, ISO 4, and ISO 5. And then shortly after, the Joint Task Force for Network Media, the JTNM, introduced TR 1001-1, which was basically a recipe guide for how to build a proper functioning SMPTE 2110 system, which has been really popularly used as a reference for how to configure your networking equipment and how to make the system from the ground up with the right conditions in general for a 2110 based system. So as I said, the work continued. The VSF, which built TR03, continued on with TR10. And there's a couple of things that were added on 2110 with IPMX. One, there's some media profiles where it's no longer optional to support 444, it's mandatory. So for example, if you support the IPMX uncompressed video profile, you have to support 422 and 444. You cannot be called an IPMX product unless you support both absolutely. There's a few other things that were added as well, such as the ability to handle digital rights. So I don't know if in any of your applications you face situations where you need to pass HDCP content between brand A and brand B. Still tricky, right? With IPMX, that's possible. There is a HDCP key exchange protocol that allows the management of HDCP keys between different brands. There's also a privacy encryption protocol, which can be used alone without HDCP, or it could be used with HDCP. It's a parallel system. This is something that allows you to load privacy keys so that you can have an encrypted multicast system where only the endpoints that are authorized by you with the right privacy keys can actually use the content. So you can have it so that your senders can send content but not be seen by any receivers unless you authenticate them. Or you could have the receivers only receive from certain senders because you've authenticated the privacy keys. So you get to manage a lot more what endpoints can participate in your multicast system. Other things that were added include a little bit more network flexibility. So as I said, with 2110, there's nothing that prevents a maker of SMPTE 2110 products from also supporting more networking conditions than the strict synchronized 2110 recipe. So in 2110, if you're following the strictest guidelines, there's 8 verifications of synchronization per second per device. This is what ends up leading to the need for very special switches, boundary clock switches that have good processing, because if you have a network with 100 devices, there's 1,600 messages per second going between your devices and your switch just checking time, and you haven't sent a single bit of audio or video yet. So that's great for systems that really need to maintain a synchronization at scale, but it could be a little bit onerous for simpler systems. So some implementers of 2110 widened the scope of the networking conditions that their products could live on, but not everybody did it the same way. So with IPMX, you have to support those networking conditions. Of course, if you have no PTP on the network, a sender must still send. If there is no PTP on the network, a receiver must still receive. It's not optional, it's mandatory. If there is a grandmaster on the system, the IPMX product must listen to it. And the default setting for all IPMX products is to be a PTP follower, meaning if you put an IPMX device on a 2110 system, it will immediately notice the PTP grandmaster of the 2110 system and use that time as the master time for the IPMX endpoint. So this is an attempt to layer on 2110 some additional useful features, and some IPMX products that will be in the market will be superset products. They will be able to support 2110 in its full implementation and some IPMX features in their full implementation. And those superset products will give you a few guarantees of being able to handle 444 content from your media servers, for example, being able to live on a bigger variety of networking systems, having the access to protocols like the HTTP key exchange protocol or the privacy encryption protocol. So there's a few things that you can get from those superset products. So let's look at the interoperability between 2110 and IPMX. So on the video side, there are 2 profiles of IPMX that are compatible with the video profiles of 2110. So uncompressed IPMX is compatible with SMPTE 2110-20. And JPEG XS IPMX is compatible with JPEG XS-based SMPTE 2110-22 products. On the audio side, the media is basically uncompressed audio over IP, which is compatible with AES-67 devices and 2110-30 devices. For those of you that use Dante, so Dante devices, majority of them can be put into AES-67 mode. When you use the Dante Control Manager to put your audio devices into AES-67 mode, they can share media with IPMX devices or SMPTE 2110-30 devices. So this is the picture. IPMX products basically behave similarly to AES-67 and SMPTE 2110 products. When there is PTP present on the network, the IPMX product will use the sync clock. The little arrows going into the senders here represent whether the signal is already sharing the common clock, the reference clock from the central system, or whether the input is asynchronous. So there's a little star next to the SMPTE 2110 and AES-67 and IPMX senders that can take asynchronous inputs and allow them to participate on a synchronized system. Usually for audio, you have to do a sample rate conversion to turn asynchronous audio into something that works on a synchronized audio system. With video, you have to do a time-based correction so that you can take your, let's say, HDMI source, which we know does not have a sync ability. So that HDMI source, you can bring it into a 2110 system, but you have to do a TBC on the 2110 or IPMX HDMI to 2110 or IPMX converter. So the thing that's new is taking an asynchronous source and being able to just deal with it with or without PTP on the system. So if all you need to do is manage sources and send them throughout a facility, the IPMX protocol allows that. It's a new capability. And that makes IPMX receivers quite flexible. If you have a display, for example, that's an IPMX display, that IPMX display can live on a greater variety of networking conditions and handle different applications. Like if you're taking a display that's going to be in a virtual production, you may want that display to be intimately capable of supporting synchronization. That same display could be used for digital signage, and it might be a completely different network that's involved. And the same equipment is able to support both of those applications. So I'm not going to read through all of these, but on the Video Services Forum, you can actually read for yourself the public specs of IPMX. It's called VSF TR10. Everything is there, including the USB specification. So one of the things that was added to IPMX is the ability to have USB interoperability between different brands. Any IPMX product that implements the USB common spec the same way, you can share USB as well. So I encourage you to look at that if you want to read what the specs support. And this is what you need to know about an IPMX product. There's certain things that are baseline requirements. All IPMX products have to support the baseline requirements. And the most important things that they need to support are how they're discovered on a network and how they're registered on a network. That's the critical stuff. An IPMX product also needs to support at least one IPMX media profile. And as I said, there's a few of them that are compatible with SMPTE 2110, like uncompressed IPMX and JPEG XS IPMX have compatibility with 2110 profiles as well. But IPMX added a few additional profiles as well. There is HEVC or H.265 and AVC or H.264 profiles of IPMX as well. Then there's a couple of optional capabilities, the things that are in green here. And then there's things that products can do that have nothing to do with the IPMX specifications. Then we talked about converters. So the new converters are doing the same thing as the old converters. They're allowing us to mix equipment when we need to. So as I mentioned earlier, sometimes the converters are able to convert the media within a protocol. Sometimes you can convert the media and the protocol. And there's different types of IP to IP converters being introduced. Some are doing just a media conversion within the protocol, like I was saying here, video format A to video format B. Okay, let's say uncompressed to JPEG XS or JPEG XS to uncompressed within SMPTE 2110 or within IPMX. Another type of converter is when we're bridging stuff that's living on an asynchronous network with stuff that's living on a synchronized system. So some converters are allowing us to take asynchronous signals, and you have a little bit of a latency introduction, but you can bring them into a synchronized system. You can allow them to participate in a system that shares a common clock. And then, of course, there's converters where you're converting the media and the protocol. So going from NDI to IPMX or NDI to 2110, these also exist. And there's different types of gateways. Some of them are simple. Like let's say you have 20 devices that are 2110 on a system and you want to bring in one NDI element. So a simple gateway will do the job. You just want to convert one stream of NDI to one stream of 2110. This is possible. Sometimes you have situations where you need to convert many to many. So let's say you want to convert 10 of something to 10 of something else. Then you're going to shop for converters that have a lower cost per conversion and can handle those bulk jobs a little bit more purpose-built. So this is what you have when you're looking at products in the market that are based on standards. It's important to understand how to shop for standards-based products. There's what the specifications mandate, and then you have what companies actually introduce. They usually introduce, the mandatory parts of the specifications. Anything that's left optional, it's uneven how they get implemented by products in the market. And of course, there's also some features that vendors add by themselves. So those are not interoperable. And then you have product performance tolerances. So, some products are built using more capable and premium technology than others. So just because a product says it can support an open standard, it doesn't necessarily mean that it has the best support for the most extreme conditions of that standard. So there are still, products that are better than others at implementing, the most extreme corners of the conditions you might face on your system. And then there's the system itself. So sometimes you have related equipment on your system that affects what you can achieve with your system. Let's say the network switch is a perfect example. Not all network switches are created equal, and depending on your application, you may need to go up the food chain a little bit and get a switch that can handle the requirements of your application. So knowing how to shop across these three elements is a very good skill set. It's an important thing to train your people on and yourselves on, and it's a good idea to form relationships where you could start to establish the tribal knowledge that is useful in your media processing applications, like what works best with what. How can I get a better guarantee that I'll get the system to behave consistently how I want in my application? Another thing that ends up happening with open standards is as there starts to be hundreds and then hundreds and hundreds and then thousands of products, there starts to be a few islands that emerge of interoperability where a couple of NDI HX products behave very nicely with NDI HX products, but they're not necessarily very interoperable with NDI full products. So it's the same thing with 2110. I can have a whole bunch of SMPTE 2110-22 equipment. It doesn't necessarily play very nicely with SMPTE 2110-20 equipment. So you have to know a little bit about the applications that your equipment are targeting and read the specifications carefully enough to understand what parts of the open standards they're supporting. Luckily, as I said, some converters exist that allow us to create bridges between those islands of compatible equipment. And some products exist that support more than one island of compatibility. So that's very useful. If you could buy some superset products, they're going to work more often in more cases with the things that you're building. So right now on the AIMS website, there's a registry of SMPTE 2110 equipment. We found that it's not particularly useful because all it does is provide a big dump of all of the products that call themselves SMPTE 2110. So next year, in 2026, AIMS is going to be introducing a new registry that will have a very, very clear listing of what products passed what tests, so that you have a little bit better of a shopping guide for knowing what you're buying. This is intended to be a tool to help you compare products and understand why one thing costs X and the similar thing costs 3X. Why is that? Well, probably there's a couple of differences in the things that they support. And so we're going to try to make it a little bit easier to shop between different things that you're trying to connect. So I'm going to show a few pictures of the growing ecosystem supporting the 2110 enhancements called IPMX. There's a bunch of source equipment, a lot of converters, some of the direct media processing equipment, and even some low-level stuff emerging. So pretty much every element on the ecosystem is either already enabled for IPMX or starting to implement it. Some of you may have seen recently on the NVIDIA website for the Mellanox API, they now have code on GitHub for IPMX sender and IPMX receiver. So good foundational support by some of the key vendors in the market using the technologies that you use in your applications. So let's look at a few pictures. On the display side, LED tile processors. Again, the same LED tile processor might be used at the highest end of a virtual production, but it may also be used in a corporate lobby. So it's very, very beneficial to support the wider range of networking conditions for products. So there is a strong support for LED walls for both 2110 and IPMX. Smart display modules. So this is a similar concept. There's something that was introduced into the market years ago called Open Pluggable Spec, OPS. That went for several years, and a lot of products were introduced and a lot of displays were introduced with support for OPS. Today, Intel has a new specification called Smart Display Module, and this is now being embedded in a lot of displays, including projectors, including some LED tile processors, including some commercial displays. So it's just an option. You know, it's still better to have a display where the technology is embedded directly in the display. But if you buy displays that have these modules, then you can, you know, as an aftermarket upgrade the capabilities of your display to these open specifications. Cameras, so there isn't actually a certified IPMX camera yet, but there are several on the horizon. Software, so there are software products that have been launched that support encoding and decoding with the IPMX protocol specifications already launched, and there's more being launched at ISE in a few months. There's lots of converters and gateways already shipping. There's some open gear products that have been announced and are also shipping. There are some products that have started using the IPMX USB specification. So at long last, it's possible to put a KVM product on your SMPTE 2110 system. Imagine how nice that is, being able to have a PC remoted to your operator desk and have a little receiver box and, you know, keyboard, mouse, display, and that's on the same system as your 2110 media. So your KVM transmitter could be feeding the thing that you're using at your KVM station, but you could also see it on your 2110 multi-viewer and the rest of your system. So this is a very, very nice level of interoperability. IP to IP gateway converters, so things that can convert within a protocol, the different media formats, or can convert between different protocols, the media and the protocols. Test equipment, so whether it's to test devices or test the system itself, so the packets on a system, the diagnostics on a system. So there's a variety of products that are introduced that have support for IPMX and more being added. Media servers, a few of them have publicly announced support for SMPTE 2110 and IPMX, and again, there's a lot more being introduced at ISE and Infocom in 2026. Right now, there's a lot of video processors, video wall controllers, presentation switchers, and other types of equipment that are starting with a lot of co-marketing using the external converters with the goal of gradually embedding the functionality inside the video processing equipment. So this is like an emerging category. There's computer-based or x86-based media processors that are on the horizon as well. And there's a growing base of IP licensors that provide IP cores for developers or software for developers. So this is going to really facilitate the ecosystem of software and hardware growing with IPMX. There's IPMX training, an official training being built by AIMS, and this is going to be free and online. You'll register on a learning management system if you want to take it, and you just have to go through the modules one by one, but there will be no charge for this. There'll be 3 levels. The designer level which is going to be introduced before Christmas. There's going to be a Pro AV Engineer Level 2, which is a little bit more detailed, and that's targeted for probably between ISC and NAB. And then we're hoping to get the broadcast level course by NAB. So the level 3 is the one where we're building interoperable systems between IPMX and SMPTE 2110 products on SMPTE 2110 systems. So I have a little example to wrap up the presentation. This is an example with LED walls. I just want to walk you through some concepts. So for your consideration, let's look at some of the elements on LED walls. Your final two nodes are the LED tile processor and your LED tiles. Some of the questions that we have to deal with are, what equipment do I need to connect with, and what type of network do I need to be on? So the answer to that question is a little bit application dependent. You know, if you're looking at a project that was done with a 2110 system, the Eurovision Song Contest 2024. In this type of system, this was, you know, a 2110 type system, and what the LED walls on this project needed to do was interoperate with synchronization on that system. So you might have a variety of different equipment in front of an LED tile processor. Sometimes you can have a source directly powering an LED tile processor. Sometimes you have a media server. Sometimes you have a video processor. Sometimes you even have these things combined in a cascade. And the combination of these things can be because of a requirement, or it could be because of redundancy. So for example, it is not rare to see some people build their systems where they have one piece of equipment driving the primary application with a rich content, but a different piece of equipment that can still handle basic scaling of sources like cameras and be able to display them on an LED wall in case the primary equipment fails, okay? So because they're all IP-based elements on your network, if I need to engage the backup system to the LED wall, it's flick of a button, and you know the LED wall never goes black. And to the concert goers or whatever, you know, it just feels like it's part of the show. They don't know that they were supposed to be seeing a special effect that is not being shown at the moment. So, you know, there's applications of redundancy, and then there's applications where it's not just redundancy. The system has an intimate relationship between the source, the media processing, and the display infrastructure. So when you're doing something with you know, GPUs to handle different resolution perspectives on an LED wall, that, you know, it starts to be important to be able to maintain synchronization across GPUs, across systems, across equipment, and you know, all of the equipment has to play ball in this scenario. So again, the equipment that I need to connect with and the system that I need to be on. Sometimes the application, oh yeah, I forgot to mention. So what does IPMX add to that type of application? So again, IPMX has some profiles that support features that might be desirable on the things that we just saw. So if you're using the uncompressed IPMX profile, support for 444 is not optional, it's mandatory. And the ability to support things such as privacy encryption between IPMX endpoints, this is a very useful feature in those events where you want to make it more and more difficult for people to put the wrong kind of content on the display or to access things that they shouldn't see on the system. So a point on best buying practices, just make sure that you read the labels properly, because some 2110 systems require minimum performance levels that your product has to be able to support. So that's a little bit of a tribal knowledge and buyer beware thing, but we're trying to make it a lot easier to identify what products support what. So the last couple of seconds are going to be on the other application of the same type of equipment. So when we're looking at this type of application of LED wall, so again, there's media processing equipment that can handle that type of scenario. And when you're doing applications like this, it may not be necessary to have the same type of system that you would in the previous example that we saw. So here, the advantage of IPMX is that maybe 2110 is a little bit overkill for some applications, and the needs may include things that are not supported by traditional 2110 equipment, like the ability to handle HDCP sources. So this is why IPMX is popular for things like these displays, because same equipment could live on different types of systems with different media with different networking conditions. So it was just an illustration and an example of what we could use the standards for. So if you have any questions, there's a kiosk outside where you can come by and engage. There's lots of expertise out there to handle any questions about this. Thank you very much.